So we're going to work on it over here on the blackboard. So do not forget, right, there are procedures that are involved in what we're about to do, okay? However, if you only focus on the procedure, it's going to make your life harder. There's a concept that's at play as well. What am I trying to do with this equation? Okay, that's the concept. Notice that's not a procedure that we're doing. We're trying to get C by itself. So at the very end, if we're solving for C, what should we have on the left-hand side? C equals. That's what I'm trying to get to. That's the concept at play. And what I told y'all before is if I'm trying to get this C on its own, what's happening to that C right now? Being multiplied by 3.2. Is there anything else happening to that 3.2C? It's being added by 5.1D. The last operation being done is the first that you want to undo, right? Because I'm going to stop at the equal sign. I'm just going to look, see what's happening to that C. So adding by 5.1D was the last thing being done, so I need to do what? Is that good? Notice, here's the thing, and this way you need to be careful about. This is saying that I'm adding D 5.1 times. Is this taking away D 5.1 times? No. So we need to be careful, and so take away D 5.1 times. And that's going to create a 0. Same thing over here. Most people, whoops, 1D. Most people, once they got here, were pretty comfortable with the next step. It's that initial step in understanding that, hey, I want that C on its own, so I need to undo the last thing being done that we're missing. But notice, by the way, this is something I've started to notice on homeworks and on quizzes, and I do want you to notice this. Am I just marking through the 5.1D?
No, you got to.
It's not that you have to, but we want to recognize that I'm creating a 0 because what is 3.2C plus 0? Just 3.2C. There's a reason why I'm making that 0. Same thing here. I'm not just going to cross through this. What's 3.2 divided by 3.2? 1. And 1 times C is just C. One single C. That's why I do that. Now, one thing I haven't talked about that I want to make sure I emphasize is, why do I need to divide the right-hand side by 3.2C as well?
What you do to one side, you gotta do to the other.
Okay, you got whatever you do to one side, you gotta do to the other. Why? Properties of equality. If I divide both sides by 3.2C, even though this equation looks different, I know it is still, that's supposed to be just 3.2. Even though it looks different, I know this equation is what to this pink one? Equivalent, right? I use a property of equality, so they look different, but they're equivalent. And this pink one, because I use a property of equality here, is what to the blue one? Equivalent. And I've created an equivalent equation. Now, if I know what D is, I can very easily find what C is. That's the point, right? If I have multiple D's to substitute in, now I can just substitute it in and very quickly evaluate that instead of having to solve the equation from scratch again. We all good with that?
Yeah.
That help us understand a little bit better?
Yeah.
Okay?
Sir.
How are we going to represent solutions for inequalities? There's two different ones.
Number line, interval notation.
There we go. Number line.
Yeah. Yeah.
Okay? Whenever we solve an inequality, we need that number line to represent those solutions. We're going to shade the solutions, meaning we're going to shade what makes the inequality true. Don't forget that. And then the other one was
Interval notation.
interval notation. We're going to recap both of those a little bit today, especially for those that have been gone. But that's what we're going to use. Now, this last one, how was it?
Hard.
Hard. So I want you to hear me very clearly on this. The question was, are these two inequalities what?
Yeah, quick up.
Equivalent, right? A lot of us are getting into the habit of just solving the equation or solving the inequality, and if they have the same solutions, we're done. But then you're missing the point. So there will be some on the test where you can just solve it to show they're equivalent. Can you just solve this to show they're equivalent?
Yeah.
Can you find out a single value that makes this inequality true?
Yo. Wait.
No.
Why not? There's two somethings.
Variables?
Variables. You can't get x equals 5. You can't even get x is greater than or equal to 5 because there's two variables there. So what do you have to use to show their equivalent?
Property equality.
Properties of equality. Well, not properties of equality in this one. You're close. Properties of
Division.
inequality.
Inequality.
Very similar ideas, but notice we're not trying to create equivalent equations. We're trying to create equivalent inequalities. Okay?
Divide by 3.
We'll get to that in a second. Okay? But the whole point is we need properties of inequalities. What else?
Oh.
What else can we use? Yep.
Distributive property.
Distributive property, right? And Jaden, that's what you tried to do at first, didn't you? Distribute. But look at what we're trying to get to. In the final equivalent inequality, is it distributed?
No.
So should we distribute?
No.
See, these are things that we want to pay attention to. You can distribute, but that's not going to show, or this isn't showing the distribution.
Right.
So we got properties of inequalities, we got the commutative, or I already gave that one away. The commutative property is the other one, and then the distributive property. What's the first thing I want to do?
Divide by 3.
You can, but I don't recommend it.
What's
Because what's at the very end on its own?
X.
X. That means I'm solving for
X.
x.
Oh.
3 is the first thing that's happening to that x,
Oh.
right?
And I don't know. That was my own answer.
Subtract something. What am I going to subtract?
2.
Just the 2?
No.
Notice that 2 is not just being added, that 2 is being multiplied. Look at what we're trying to get to. Minus 2 times y minus 4.
No.
If I subtract something from itself, what am I going to get?
0.
I know that's a lot more complicated than we're used to, but it's still the same concept. If I subtract that entire expression, I'm still creating a 0. And so now I have 3x is greater than or equal to 5 minus 2 times y minus 4. So close. What do I got to do now?
Divide by 3.
Now I want to divide by 3.
So yes, very true. Like I'm
Are those the same?
saying. Yo.
Yeah. They are equivalent, okay? I use my properties of inequality this time to show that they're equivalent. You can also use that distributive property and that commutative property as well. There's a handful of others, but those are the main ones. Really quickly, one thing I want to point out. I'm going to make sure I bring some actual washcloths up here. I have a towel, so don't use that one today, but I'll bring some washcloths. This is space for you to show work. Personally, I just like to do something different. Writing on the whiteboard got boring. Writing on the desk might get boring. Now granted, that's newer for y'all. I do that regularly, right?
Yeah.
If you want to use this, I'm more than happy to let you use it. You can also come in during enrichment and do some artistry or whatever you want to on it. This wall is for students to do what you want to with it as long as it's appropriate. Okay?
Robert.
So, nothing inappropriate on the wall. It'll automatically get eliminated or erased. But this is a great place for you to show your work. Take advantage of that. Ready to get started with today?
Yes.
Cool. So, today is our last day on inequalities, and then we will start on the review for the test, with that test being the first half of Friday.
So I'm not taking this class.
No, so, did I tell you why I changed it?
No. Yes. For the 4-day weekend.
Yeah, like,
Oh,
should
God, we
I
got 4-day weekend. When?
this weekend?
Why?
Monday is Labor Day, and then y'all, teachers have a work day on Tuesday, so y'all just come Wednesday through Friday.
Yeah. Get something.
Please don't tell me stuff like that. And the camera's still recording.
Then I ain't got to go to work Monday.
Okay, so let's get started with our agenda. We're gonna do a quick unit recap, and then we're gonna finish up lesson 20 and give you some chances to ask questions about the inequality homework. As I said, that lesson 20 inequality homework is due when? Wednesday. I know that's not a Thursday, but that's 2 days later than it should be due. So I think that's fair. Is that safe to say?
Yeah.
Okay. The reason why I'm doing that is I want y'all to have that extra time to focus on the review packet that I've created. Robert, why are you this way? Okay. So I need everyone's heads up, and I want you to go ahead and get out a sheet of paper. Because here's the thing. I was talking about it with my first block. Have any of you actually gone back through the lessons to ask yourself, hey, what are the major things we need to know?
No.
No? Even though we've already taken a quiz on some of this?
No.
One of the best study strategies that you can employ is making sure that you understand every major topic covered. What is the very first thing that we studied in this class? Don't pour that on the desk. Just wipe it off.
Come on, sis.
I'll clean with the expo stuff later. Just, okay.
It's red, man.
Yo, what is the very first thing that we studied at the beginning of the year?
Statistical and non-statistical?
Statistical and non-statistical what? Questions, right?
No.
That's something that might show up on the test, don't you think? Yeah? This is a recap of key ideas. These are all the things that you need to understand if you're going to be ready for that test.
You need to write down on a piece of paper?
I might even title it Recap of Key Ideas for Math. Robert, you're not funny. I'm trying to record this so that people can watch it later if they need it. Like, so, please understand, what I'm doing is modeling for you something that you should do on your own moving forward. I might do this one more time, but when you go to get ready to study for a quiz or study for a test, go through the lessons and say, what are the major ideas, and do I understand what they're about, and can I do them, right? Do I understand the concept, and can I do the procedure? Those are the two important things. Was there anything else with statistical versus non-statistical questions?
I thought they said us.
Versus.
Like this.
Is that better? Okay. Statistical versus non-statistical questions. Anything else that was with that idea? Think about all those bell ringers we did.
I don't even know what that week will happen to you.
I asked you all to make statistical questions that had numerical data or categorical data. See, this is why you need to go back through those lessons. This is something that should be on the tip of our tongues because we studied it for so long. Right? So, statistical versus non-statistical statistical questions and numerical versus categorical data. That is important. That could very easily show up on the test. Okay? It's okay. You made the same mistake. He's just looking out for you. What other ideas have we studied so far? What was the next idea?
Inequalities.
Actually, inequalities is what we're on now. What did we study first after the statistical versus non-statistical questions?
Equivalent.
Very close. There's something right before equivalent.
Property.
That was part of the equivalent.
Mouth. You mean here. What is a solution?
Thank you.
Oh, yeah, true.
Remember, solution was the very first thing when it came to equations and inequalities. The idea of a solution comes up throughout mathematics. All of this year, you will hear me talk about solutions. All of this year. All of this semester. Thank you.
Yeah.
Okay? So what is a solution?
Something to make a variable. Is that it? A variable that make the equation true.
It would no longer be a variable, a
Okay.
value.
Yeah, that's it.
A value or values that make not just an equation,
Expression.
or an, not expression,
Statement.
equation or
Inequality.
inequality true. Right? It makes a mathematical statement true. An expression is not a mathematical statement. It can be an equation or an inequality.
See, I ain't know nothing about inequality.
So, yeah, we're catching up now. What was after solutions though?
Equivalent expressions.
Okay? Just in general, not just, yeah, let's go ahead and say equivalent expressions, that will be part of it.
Wait, what's this part of the test?
Yeah.
Oh my God, I thought we were writing it down.
No, it's a recap of key ideas. These are the main ideas that you need to understand and be able to work with to be ready for that test.
I'm gonna fail part of it because I don't know inequalities.
You still got 2 days.
Oh, I thought it was
It
tomorrow.
won't take that long.
How many questions?
Here's the thing. All I'm doing right now is recapping the key ideas. Go through your notes and look for this. This should be in our notes heavily, right? This is this is the applications of equations lesson. This was lessons 6 and 7. Beyond equivalent expressions, we also had equivalent what?
Values.
Equations.
Wait, I didn't say that already?
You just said expressions. Equivalent equations. Are there any ideas with equivalent equations that we should be thinking about?
Ain't it, I think that was expression. No, I think you say expression, some about the problems don't look, hold on, I got it written down.
So what you're thinking about is what is an equivalent expression, right? So they look different, but they're still the same. But what I'm asking is, if I look at equivalent equations, there's some key ideas that we actually talked about over there that determines if they're equivalent or not.
The solution?
Do we have any solutions for the warm-up problems on the bell ringer
Today?
today?
You asked.
Yeah. Like 3.2c plus 5.1d is equal to 10. Was there any solutions that we looked at there? No? So how do we solve for c?
Equality.
There we go, right? If I'm talking about equivalent equations, the first thing we should be thinking about are the properties of
Equality.
equality.
J-quality.
Was there anything else that we could use to create equivalent equations?
What did it start with?
Well, not for an equation. We do have properties of inequality, it's going to be later. Were there any other properties that we used to show equivalency? Okay, so one of them was commutative. What else? Distributive. Right? So we want to remember those equivalent equations. We got those properties of equality, we got our commutative and distributive properties. We should know where these ideas come up so that we can go back to those lessons to study them. What were lessons 8 and 9 about though? Still about equations, but in what regard? That's not till lesson 20. That's what we're on right now.
So we got the bad mirror.
I mean, you could pull out lessons 8 and 9 and look. It's pretty similar to what number 1 was on the bell ringer. What did we do in the first one? Still up there. We solved for C, so solving for a specific variable. Yeah. Okay? So solving for a variable, and what we typically call it is a variable of interest. Right? So solving for C, solving for X, solving for Y. That was 2 whole lessons, that might be important. You have homework associated with it too. That'll be given back tomorrow for those who have turned it in by today. And what are we going to have to use in order to solve for a variable of interest?
Properties.
All the properties, right? The whole thing is that we're trying to create an equivalent equation that highlights a variable of interest, so I need to use my properties there. What about lesson 20? Inequalities.
Yeah.
Oh God. What's that?
She said, how did you go from 8 to 12?
Because this is algebra 1, not algebra 2. There's a whole unit, or within where I pull this resource, these resources, there's a whole part about linear equations, and we're going to do something different to tackle that.
So you pull your research from the internet, which you need all of your answers.
No. I pulled task from another resource. My quizzes and tests will not be on the internet.
So
I make those myself.
So if we send homework, so internet.
You can find it on the internet. It won't help you on quizzes and tests if you cheat. And also remember, you have to justify your answers.
Photo mail.
It's not going to help you.
I'm gonna show you.
All right.
Show you this.
Solving inequalities, which don't forget, we're thinking still about equivalent inequalities. And then the different properties. The final thing to remember within that, because this will come up on the test, is how we're going to represent our solutions for inequalities. Number line,
And interval notation.
right. Represent
What's an inequality? You must be short of inequality.
INEQ,
Oh, okay.
where
Right, in the green, I have to make sure.
yes, INEQ is inequalities. Represent solutions with number line. And interval notation.
This study got really great.
Well, the test is a grade that
So
that study guide might help you with.
So
That's what we're working on in class tomorrow. And I would suggest working on it as much as you can tonight so that you know what questions you need to ask when you come to class tomorrow.
I've got work, so it probably won't be a lot if I
Okay.
do work on it.
So, I want y'all to notice, and this is something legitimately that y'all need to do. I might model this one more time for you. But all I did was I started at, what was the first thing we studied? What was next? What was next? What was next? And I have the main ideas here. The main topics, the main vocabulary that showed up through each of those lessons. You need to know what each of them means and how to use those ideas for a test. What does each idea mean and how do we use them?
You doing group work today?
Alright. Yes, we were doing group work today.
Yeah, don't we do that every year?
Yes. For the most part. Tomorrow could be a little bit more independent, but you are still to help each other learn and grow.
Yeah, good.
Alright? If you're still writing down, continue writing, but I want to look at the objectives. So remember, we're trying to solve inequalities, right? There's one thing we completely forgot to add up here. Throughout all of these things, what have we always done that is not up here right now?
Justify.
Well, always justifying, but specifically for this unit.
Write equations, equations and inequalities
How many did you say that?
for a situation.
We have solving equations and inequalities throughout here, but remember how I've been giving all word problems and we have tried to write equations and inequalities off of that?
Oh yeah,
That gonna be on test?
That will be on the test.
What? Oh yeah.
I mean, has it regularly shown up throughout the whole unit?
Yeah.
Yes. If there is something that shows up on every single lesson, yes, it will be on a test. Okay? So write equations and inequalities for a situation. Okay? And so this is what helped me remember that, right? Write and solve inequalities to answer questions about the situation. Okay? What we're going to focus on today, though, is that first objective, right? Of solving an inequality by using a related equation. It is much easier to solve an inequality based on some related equation. Can I erase through lessons 8 and 9 here? We all have all that? Okay. So, if y'all remember, or hopefully y'all remember from this quick conversation yesterday, the properties of inequality and properties of equality are very similar, correct? Well, you weren't here yesterday. But like if I have 3x is greater than 15, what would I do there?
Solve it.
Divide by
3.
3, okay? And so I'm left with x is greater than
5.
5. And so if I if I test a number, what kind of number should I be thinking about for solutions?
A number greater than 3.
Not greater than 3,
Greater than 5.
greater than 5. Give me a number.
6.
6 and 7, let's check them. 3 times 6, is that greater than 15?
Yup.
Yep. 3 times 7, is that greater than 15?
Yup.
Yep. Okay, so there we can very quickly see just a handful of solutions. This is why we need though number lines and interval notation to show all of them. But what if I had negative 3x is greater than 15?
You need a number that is greater than. Oh, you giving us a number? 10.
So I'm going to divide by negative 3. And if I leave it like this, what's a number greater than negative 5?
1.
1 is greater than negative 5. Negative 3 times 1, is that greater than 15?
Oh.
Oh, no.
I'll think of 5.
What's the mistake? Something with that negative. Whenever you multiply or divide by a negative, you're actually supposed to reverse the direction of the inequality. And it's not just that you're supposed to. For the inequality to stay equivalent, you have to reverse it. Okay?
Hold on,
So what's a number less than negative 5?
1.
Not negative 4,
Negative 6.
negative 6. Right, here's negative 5. Less means to the left. So if I try negative 6, what's negative 3 times negative 6?
Negative 20. I mean, negative 18.
18. A negative times a negative is a positive. Is 18 greater than 15?
Yeah.
So you see how we're supposed to reverse the direction of that?
Leave that up.
Okay, but here's the thing. It's hard to honestly remember when you're supposed to reverse the direction or not, and there's a much easier way to do it.
How you do?
This is what we looked at yesterday with Andre. This strategy from lesson 20.
Oh.
You already have lesson 20, right? Yeah, because I gave it out. No, you don't. Did I ever give you a copy?
Don't even.
I'm not. I have to print out a copy for you, Kyron. I'll do that in a second, okay? Does anyone else need a copy of lesson 20 because they haven't been here at all when we've gone over it? I do need to give it. Okay, so I'll print 2 copies for you. Okay, so if you look at Andre and Priya, they had a nice and complicated inequality here. Did they even work it as an inequality though? No. What did they make it right away?
One more time. They call the walk. Good dog.
What did they do right away? That's not the first thing they did.
And that.
Nope.
Parentheses.
Is that what it was too?
Multiplication.
2 is still there. 2x plus 1.5 is still there. 18 minus x is still there. What do they do this less than?
They equal.
They made an equal sign. It is easier to work with it as an equation. This is where we left off yesterday. It equals 18 minus x. Now what would we do?
2 times 2.
We can distribute, can't we? Yeah? 2 times 2x,
4.
4x. 2 times 1.5. You can use a calculator.
3.
There's a 3 though. Now what would you do to solve from here?
Combine like term. Wait, no,
Minus 3 on both sides.
yo, property equality.
So we can use properties of equality now.
J equality.
Notice that creates a 0.
Yo,
So 4x plus 0 is just 4x.
equals 15 minus x
Now,
plus x.
notice I want to make another 0, right?
Yo,
So that those x's are only on one side.
yo, 5x equals 15, x equals 3.
Okay, so x is equal to 3.
Yo,
So if I were to create a number line here, what number would have to be on that number line? A 3, right?
yo.
Now, the whole point is to identify the what for the inequality.
Is it greater or less?
We're trying to solve it, so we want to identify the,
The value.
not the answers,
The variable. Solution.
the solutions, right? What makes the inequality true.
True.
I know 3 needs to be on here, but is 3 itself a solution?
No,
Why not?
cause that ain't greater than, hey, yeah, it ain't greater than, yeah,
How could we figure out if 3 is a solution?
plug it in.
Can we substitute it in?
Yeah.
Okay, so 2 times 2 times 3 plus 1.5 is less than 18 minus 3.
So 2 times 6,
2 times 3 is
6,
6 plus 1.5.
7.5,
Okay. 18 minus 3 is
18 minus 3, oh, 15.
15. And what's 2 times 7.5?
Use a calculator. Oh, 15.
15.
No.
Notice they're equal, but is it less?
No.
Okay, so it's not a solution. So when I put a point at 3, is it going to be an open point or closed?
Close.
Open.
Open is when we indicate that it is not a solution.
Oh, you know what that
If you
is.
close it in, it's a solution. It means you can equal it, right? Now, which direction am I supposed to shade though?
No.
I didn't do it as an inequality. Why do you think it's to the left?
Cause it, right.
Okay, so you're saying that I should go to the left, correct? Is that what he's saying?
Yeah.
Yo.
How could I figure out if those are in fact solutions?
Oh, hold on.
Plug one in and carry it out.
Can we substitute a number in from the left-hand side and see if those are solutions? This 3 that we found over here is known as a critical value. There's more technical language with it, but a critical value, essentially you plot it on the number line and you test around it to see where the solutions are. If I test, which I always love 0, let's test 0. What's 2 times 0?
0.
See, that's why I love 0, right? That's a 0. 0 plus 1.5 is?
1.5.
Okay, so 2 times 1.5 is?
3.
3. Still need to do the right-hand side, so 18 minus 0, that's 18. Is 3 less than 18?
Yeah.
Yo.
So are these solutions?
Yo.
Yes.
Which probably means stuff to the right are not
Not.
solutions.
Oh.
Let's check it. Because if we're going to claim that they're not solutions, we need to check. So I'm
Go.
testing I'm testing 5.
Yo.
2 times 5?
5.
And
Oh.
2 times 5. 10, right? 10 plus 1.5,
11.5.
Yeah.
and then 18 minus 5 is 13. Is 23 less than 13?
No.
So we're supposed to shade to the right?
No.
It's a simple way to think of that. Cause one of my teachers told me like, whichever way
Inequality?
yeah, whichever way it's facing, just go the opposite way.
Okay. So,
See, like the butt part faces the left, so go the left way. But
so we're going to the left?